Okay, so problem 3. For a given variable, solve this. A lot of students just solved these equations. These are just equations. Like, you're using your simplifying steps to solve these equations. And some students were just using some students were just doing this like a normal way. They were removing balance sets just like we normally would because they had calculators. The purpose of the lesson, though, the reason why we included these in here was to show when you see something that's like a big scary, when you see something that has these big scary decimals that a lot of students feel very unsure about, one thing that you can do to get rid of decimals is to try to turn them into whole numbers. And so to do that, what they want you to do, or one way to do it, is to multiply both sides by whatever the furthest decimal place is. So in this case, all of my decimals are in the tenths place. So because of that, I decided to multiply everything by 10. 12.8 times 10 turns into 128. Notice it looks the exact same, but there's just no decimal in it. But I also have to do 10 times 6x, and I know 6 times 10 is 60, so this is going to turn into 60x. And then 14.6 times 10 is going to turn into 146. So some students just become, even though like you should come up with the exact same number either way, sometimes this is just less intimidating for students. So that's why we went over it. But now I would need to remove balance sets. I see I only have x's on the right, or sorry, on the left. So I'm going to get rid of all of my ones on the left and put all of my ones on the right. So no more ones on this side. So I'm going to subtract 128 from the left, and then I'm going to subtract it from the right to balance it out. And I will be left with just 60x on one side, and 60x is going to equal 146 minus 28, which is 18 on the other side. And then when now I need to get rid of the 60. It's 60 times x. So I am going to divide by 60 on this side and divide by 60 on this side. And then I should get x. And then 18 divided by 6 would be 3. 18 divided by 60 would be 10 times more, so or 10 times less because we're dividing, so it would be 0.3. So that should be my answer here. Some students came up with 0.33, like 0.3 repeating. Students that were doing that is not a close enough answer. Students that were coming up with that number were coming up with it because they did math wrong somewhere else. If you said 0.3 repeating, you got this one wrong. Moving on to B, let's see, for B, same thing, right? In this case, over here, we were trying to turn these into whole numbers. That's what we want to do here too. I see that we're dividing by 6. There's lots of ways to solve this one, but the way that we were teaching in class, if you did it a different way, it's fine, but we were teaching that because we have something getting divided by 6, we should multiply by 6 to undo that. And so we have to multiply 6 times 9, which is 54, and 6 times h is 6h, divided by 6 is just h. So when you do 6 times h divided by 6, it just turns into regular h. These two things cancel out, and all you have left is h. 6 times 99 is, 6 times 90 is 540. 6 times 9 is 54. When you add those together, you get 594. And then if I subtract, and then that's my equation with whole numbers, and it's less scary. And then if I subtract a balance set from both sides, I come up with h just by itself is equal to 540. So that's what you should have come up with here. Okay, the last one is the one where we sort of start putting all this together. I need to get rid of all of these things that are being divided all at the same time. And so what we talked about in class, there are lots of ways to do it, but in order to get rid of this 3 and this 7, in order to get rid of the 7, I have to multiply by 7. In order to get rid of the 3, I have to multiply by 3. And in order to get rid of this 21, I have to multiply by 21. But I have to multiply everything by all those things. But if there's one number that that's divisible by all of these, I can just pick that. So 21 is divisible by 21, 7, and 3. And so if I multiply by 21 here, then what I'll do is I'll do a little cancellation. This 21 divided by 7 turns into 3 times 8a. And 21 divided by, let's get another red. 21 divided by 3 turns into 7 times 2. So instead of it being 21 times 2 divided by 3, it's now just 7 times 2. And then on the other side, 21 divided by 21 is 1, so this just turns into 62 times 1, which is 62. Let's see, 62 times 1 is 62. And then now I just do this simplifying math, right? I have, I know 7 times 2 is 14. I know that 3 times 8 is 24 times a is 24a. And I know 62 is 62. So what I've done is by multiplying by 21, all of my terms, this is plus. All of my terms when I multiply by 21, this term is now 21 times bigger, and when it gets 21 times bigger and you simplify it, it turns into 24a. This term here is 21 times bigger, it turns into 14. And this term here is 21 times bigger, it's just 62. So because both sides got larger by 21, that means like this is still a balanced equation, because if one side of the teeter-totter gets bigger, the other side can also get bigger. So then I need to just solve. So I subtract 14 from both sides, and I get 24a equals 62 minus 14, which is 48. And then I get rid of this 24 by dividing by 24. Divide this side by 24. And so a should equal 2. And that should be your solution. Okay, so problem 4 says Mia gave her waiter a $4.76 tip on a $28 bill. What percent tip did she give? Now, I actually saw students solve this in 2 different ways. I'll go over both of them. So one way, the way that I would solve it is I always associate the starting amount with 100%. So $28 bill is the amount that we're supposed to pay. That should go with 100%. And then the portion of that is the percent. This is a percent increase. So this is an increase in money of $4.76. And the question is, what is the percent that goes with that? So it is X percent there. And so same thing, like there's so many different ways that you can solve this problem. And you can use the C method or the butterfly method or anything like that. If I was to solve it, I might use the butterfly method and say that $28 times X is equal to 476 times 100%. And then I would get 28x equals 476. And then I would divide that by 28. To get x by itself, and we would get x equals 17%. So it's a 17% tip. But there's a lot of students that solved it in a way that was not a way that I have gone over in class, but I really liked it. But it sort of reassociates these numbers. So we've talked about how you can lay out these in any way as long as you have the associated numbers going like never diagonal from each other. So the percents lined up with the percents, and the 100 still need to be lined up with the 28. But I can also say, well, I know that if I wanted to know a percent, I want to know what percent out of 100% goes with the money. So I know that the money that goes with X percent is 476, and then I know that the money that goes with 100% is 28. So if I just do this math, it's going to give me X, because 100% is just the same as 1. So 4.76 divided by 28 should give me that amount of money. And when I type in, or it should give me that percent, and when I type in on my calculator 4.76 divided by 28, I get 0.17. Now, if you just told me that, that's not really good enough for an answer because it's not a 0.17% tip. You still need to convert this into a percentage. But we also went over that, and if you just multiply this times 100, you will get a 17% tip. So either way works. I really like them both. For B, it says a store owner had a sale on a deli platter that went from 1950 to 1625. What is the percent change? Again, there are two ways to figure this out. First of all, we want to know what we need to figure out the percentage of the change. So I know that there's two ways to solve this. Some students, they said 1950. I want to know what the difference is. If you subtract 1625 from that, you will come up with $3.25. And then what I want to know is if I know what, so this is this $3.25, this is the change in the price, right? This is the price change. So what I want to know is what's the percent change? So what is the percent that goes with 325? So I know that 1950 was the starting amount. So the percent that goes with that is 100%. And then that is going to be equal to some percent that goes with $3.25. So again, all of my different ways of solving this, I can say, I can just like do the C method or something. So 3.25 divided by 19.5, and that will give you 3.25 divided by 19.5 equals 0.16 repeating, 1 with the 6 repeating after it. And then if I multiply that times 100, so that gives me my decimal, but then when I multiply times 100, it will give me 16.6 repeating percent. So in this case, X is equal to 16.6 repeating percent. Okay, so those were our sort of percent proportions. Oh, I wanted to say another way that you could do this. The other way that you could do this is if you were to, let's shrink this down. If you were to do this math again, you could also, what a lot of students did was they said, well, 100, they said 1950 goes with 100%. And then they used the other number they had, which was 16.25, and they know that goes with some percent. And when they do that math, they do 16.25 divided by 1950. And they get so when they do this division problem here, they get, 16.25 divided by 1950 equals 0.833 with the 3's repeating. And then they multiply that times 100 and they get 83.3 repeating percent. So some students said this, that's not the percent change though, that is the percent of the original price that you still have. So that's what you're still paying. 16.25% is not the change in price, it is the new price. So this isn't the change in percent, it's like the new percent. So if you wanted to figure this out, remember at the very beginning, in order to figure out the change, we subtracted the starting amount from the new amount, subtracted the new amount from the starting amount to get the change. If you do this math first, you need to subtract the starting percent from the, you need to subtract the new percent from the starting percent. So you need to say, well, 100% minus 83.3 repeating percent, and you will get 16.6 repeating.